Hello everyone and welcome to this special video where I would tell you why the number 184467440737095511616 is my favorite mega number. But why and from where this number came from, you ask? You will know after I actually talk about a bit of digital computing, electronics and much more cool stuff. So stay tuned till the end of this video, and by the way, the video is divided into chapters if you would like jumping into a point directly, and let's get started. Let me ask you to calculate 8 plus 3. What you will do is actually memorizing the number 8 and memorizing the number 3 in your mind, and using your brain you will calculate a new number which will come out, which you will also memorize. Similarly, in a CPU or any type of computers out there, there is something called registers, which are super fast storage holders where you could assign the numbers and perform any mathematical calculations of any kind. Cool, right? But how do you tell the processor to do 8 plus 3? Well, you give it an input, a series of ones and zeros, so that the processor could execute and output the needed result, and this input is called the instructions. Whenever we are talking about digital computing, we always talk about ones and zeros, high or low, or something like that. Let's now talk about how is data or instructions are sent to the processor through the data lines. If you have one data line or one physical connection or wire, you can only send either 1 or 0 at a time. That means 1 bit at a time, which is very slow and extremely inefficient. If you increase to 2 data lines, here you can actually have 4 different combinations or values, which is still pretty small value, so let's crank it up a bit to 3 data lines, or more technically, 3 bits of data bus width. But as you hit 4 bits, things will get bigger. At 4 bits, you could have 16 different combinations or states, enough to hold a value from 0 to 9, plus first 6 alphabet letters. There is a very easy rule to use, which is 2 to the power of n, where n signifies the number of bits you have. So if you have 1 bit, that means 2 to the power of 1, you will have only 2 different combinations. 8 bits, that means 2 to the power of 8, you will have 256 different combinations, and so. The data bus is shared with all of the modules in a computer circuit. So the data bus is shared to the RAM, ROM or any peripheral device. Also, by using an address bus and some signals, you can pick from where to read, write and do some awesome stuff. Now some examples. The Raspberry Pi Zero uses a 32-bit data bus. That means it could deal with 4 bytes of data at a time. And in terms of combinations, a 32-bit data lines could have one of more than 4 billion different combinations. Yet an Arduino Uno, for instance, as it uses the known ATmega328 microcontroller, and by the way, I have already made a video about the difference between microcontrollers and microprocessors, so be sure to check it out. The Arduino Uno has only 8 bits wide data bus, not 32. Another example is the Z80 processor, which is an 8-bit processor having 8 bits wide data bus. Here is my 8-bit computer on the breadboard. You can see that the data bus is shared to different places along the circuit. I will definitely talk about this circuit in future videos and so if you are a future viewer, expect seeing some cards and links everywhere. A modern computer, by contrast, has a wide 64-bit data bus. It could deal with 8 bytes of data at a time, which is huge. And how many could a 64 data line do in terms of combinations, you ask? Well, let me calculate it. So here is it. A little bit. Wait a little bit. It's this big number, which is my favorite mega number. And that's the end of this video. I really hope you enjoyed it. If so, don't forget to like and comment if you would like. My channel talks about electronics, programming and some cool stuff. If you like that, maybe consider subscribing, and thanks for watching.